Good, grade 11. So we're looking at the trigonometry. We are going to look at these questions on the next slide. So, just the interesting fact, this is the stuff that we normally see at optometrists. Do you know what the optometrist is? And then they ask you, can you see that? Interestingly enough, I'm going to send a shout out to my girlfriend. She never watches my videos, but yeah. She works at the optometrist. I'm going to say her name now. Hello, baby. No, I'm just joking. Her name is not baby. All right, let's go on. Um, all right, so there we have question one. They're given to you. Now, what you're supposed to do at this question, I know it's in Afrikaans. I will put on the English later when I am editing the video. All right, so you have here this given sketch to you. All right, so what you're supposed to do, you're supposed to draw in on your sketch a imaginary line that is perpendicular to the y-axis. Not perpendicular to, sorry, perpendicular to the x-axis or parallel to the y-axis. So then you're going to say, but this now means P has the coordinate of 7 and negative 12. So that means the length of x is 7 and this distance is negative 12. Now, what is unknown to us is the hypotenuse. And we can determine the hypotenuse in this case with Pythagoras. So let's quickly see if we can do that. So now this is x and this is y. We normally refer to the hypotenuse on the Cartesian plane as r. So right, so I'm going to say r squared is equals to x squared plus y squared. So now I'm going to do substitution, as I know this is the theorem of Pythagoras. So that's going to be 7 squared, which equals to 49 plus negative 12 squared. Please, this is going to become a positive. So that's 49 plus 144, and then my answer is Asange 193. All right, so the square root of 193 is the value of r. So what I would do always, would go write it in on my sketch there, 193. I would put it down in my sketch. Now I have all of the sides of the triangle. Now I haven't even looked at the questions, but now I have everything that I need. All right, when it is not the hypotenuse, you should remember that we were going to subtract from the hypotenuse. No, just make a mental note there for yourself. If it's not, say for example, you are given the hypotenuse, say they gave you this was 190, the square root of 193, but you need to determine for x, and you're given y, then you're going to use the square of this minus the square of that. All right. So now they ask you to determine, so we actually have already determined the first question because they ask you for the length of OP, and in that triangle, so we can just go right, OP is equals to square root of 193. Now you can go write it as a decimal form, but for this we're going to leave it in this way. So there 193 units because we're working with distance. Now we're going to work from the next one. They ask you 1.1.2, the sine of beta. All right, now the sine of beta is simple. We're just going to use what we are having. So I'm going to stand in this perspective. That's my perspective, as you can see me there. No, I'm looking from that perspective, and I ask myself, what is sine again? Sine is opposite over hypotenuse. So the opposite here will be negative 12, and the hypotenuse will be square root of 193. Then if I look at 1.1.3, they ask me the cos of beta. The cos of beta will be adjacent over hypotenuse. Now, as you can see, the adjacent here is 7 and this hypotenuse is 193. And also another way you can check, because it's in the fourth quadrant, cos is positive. No? So therefore, here we got a sign being negative. Because sign in the fourth quadrant is negative, but cos is positive. You can leave your answers as that. Now they ask you number 1.4 is the product of, no, it's the quotient. All right, they'll ask you sine of beta over cos of beta. So once I have worked out my sketch and everything is on my sketch, so the most important part here is working from your sketch. Then I can just go do substitution, simple substitution. This is going to be, I already have the answers, negative 12 over square root of 193, and I'm doing division. I'm going to divide this by 7 over 193. But as I know, once I'm doing division of fractions, I can actually multiply with a reciprocal. So that's 193 over 7, and then this one and this one cancels out, so I'm left with negative 12 over 7. And now they lead us to the next question. I already know what the next question answer. So they ask me for the tan of beta. So now I go back to my sketch. Tan is once again opposite over adjacent, so that will be 12. In this case, negative 12 over 7. And what they want you to see here is that the sign, this is called the quotient identity. If you didn't know that, that's called the quotient identity. The quotient identity looks like this. Tan of beta is equals to the sine of beta over the cos of beta. All right, we're in grade 10, I think, or grade 11. We also have the other identity. We're going to look at some more identities in grade 12 and also in grade 11. This is called the quotient identity, and the other identity is called the square identity. Because if we say sine squared of beta plus cos squared of beta, it's equals to 1. That is called the square identity. All right. Now they ask you, use your answer in 1.1, 0.1 to 1.5, and make, what is that word? Conjectures, veronderstellings. All right, so they basically want you to conclude to the identities that tan of beta will be equals to sine of beta over cos of beta, and that's called the quotient identity. And the other one, in this case, yeah. Now they ask you at 1.3 is they ask you to work out the 1.3. They ask you to work out sine squared of beta plus cos squared of beta. All right, so let's go do that. Sine squared of beta. 1.2's answer is where are you now? No, you were supposed to 1.2. You're supposed to make a conjecture. All right, so there you just say that the tan of beta is equals to the sine beta over cos beta. So that's actually a trigonometry identity. That is the conjecture that you were supposed to make there. Now at 1.3, we're going to say that, oh, we need to determine or calculate this. So what is sine of beta? If we work out sine is negative 12 over square root of 193, but this is sine beta squared, plus cos of beta will be 7 over square root of 193. Then we square that as well. If I square that, that becomes 144 over 193 plus 49 over 193. If I add these up, it's nice for me to add them up because the denominator is already the same, so I can just write it as 193 over 144 plus 49, and that equates to 193 over 193, which equals to 1. All right, and that's why, so we can conclude that that is actually our square identity. All right, I'm going on with this. I'm going to look at question number 2 now. All right, just give me a second so that I can see if maybe I can get question 2 on the board there for us. All right. Question 2, use fundamental identities to simplify. All right, let me see where I can write. So I'm going to start with number 2, 2.1. We're supposed to simplify this, so we're going to say square root of 1 minus cos x and 1 plus cos x. All right, I'm going to simplify this. This is going to be 1 times, so what is this actually? If I look at this, and this is supposed to remind me of something that looks like this. This is the product of the two products of a difference of two squares. All right, so that means if I multiply this out, and you can go multiply out, you will see that the middle term is going to cancel out. So you're basically going to get the square root of 1 minus cos squared of x. I am recording. It's recording, yes. All right. So now, if I look at this, no, there's a diversion from this. If I want to write, for example, sine of beta, if I want to make this the subject of this, then that means it's going to be 1 minus cos squared of beta. So that means if I'm given this 1 minus cos squared of beta, or of any angle, I can convert that, and then it's going to be sine squared of beta. Now where is that? So now I replace this identity, and then it becomes this I got from here, no? And this now becomes not 1. I have this, so I'm going to sine. So that becomes sine squared of the angle. Don't change the angle there. This angle is x. And what is the square root of a square? It's just going to be sine of x. All right, grasp your head up around that a little bit. I first used this and I got to that answer. All right. Then from there, I used the square identity and I made sine the subject of the square identity. But then I saw when sine is the subject of the square identity, it looked like exactly like that. And then I replaced this with sine squared of x. All right. And then I just simplified from there onwards. Yes, you can. Good. Grade 11, we're continuing with question number 2. I just want to see, let me just allow me to put it on the board quickly. So it is this one. All right. So we have the sine of x. I'm going to do it here, 2.2 sine of x, and then bracket sine of x plus tan. Now when you see tan in a expression like this, the first thing that I would go do, I would go rewrite tan in as its sin over cos. So I'm going to write sine of x over cos over x multiplied with cos of x over 1. Now I check, is there anything that can perhaps simplify? This one and this one can simplify. Alright, so I'm left here with sine of x and sine of x plus sine of x. So basically that now becomes sine of x, because Botman says I need to simplify the bracket first, so that becomes 2 sine of x, and then I multiply that, so that becomes 2 sine squared of x. Right, let's go on to the next one. Cos of x plus sine of x squared plus cos of x minus sine of. All right, I want you to do this, no? But I'm going to give you 3 minutes to do. First, do for me. Before you do that, do the following: a plus b squared minus, sorry, plus a minus b squared. Do that for me. All right, and then we're going to do, because sometimes the at number 2.3, sometimes we get confused when we're doing multiplication of sine of x, but we should just remember our basic algebra that applies there. So I'm going to pause there, and I'm going to give you, we're going to an interval. See you right back after the interval.
Well done, Jason! Go, go, go! Go, Jason!
Good. Welcome back after the interval that you had there. We're just going to look at this as our last part for this lesson quickly, and then I see you in the next video. So we're going to finish up here. All right. So what we can do here, we're working from this identity, and once we work from that identity, we can see that the first one is going to be, if I expand, so 2.3, I'm going to go write out the expansion first. That's going to be cos squared of x plus cos of x sine of x plus sine squared of x. That is just the first one. No? Then if I go on, it's going to be, sorry, that's going to be 2 cos x sine x. Thank you for that. Then the second one is going to be plus cos of squared x, and then minus 2 sine of x cos of x plus cos squared of x. That's a plus there. All right, now what I can see here is that this is actually like terms, and then those, that's a positive and a negative, so they cancel out, and then I have cos squared of x plus cos squared of x. That gives me 2 cos squared of x, and then this one is going to give me sine x, sorry, sine, this one is supposed to be sine of x now, sine squared of x, so that's going to be plus 2 cos squared of x. Sorry, 2 sine squared of x. And yeah, if you want to, you can simplify this to cos, look here, cos squared of x plus sine squared of x, and then the magic happens, because this is once again, what is this? Say that again. This is the square identity. No? So that means that's 2 times cos squared plus sine squared is equals to 2 times 1. So your answer is 2. Lovely, eh? Now, let me go a little bit further and show you how you can check if this one is right. No? Don't tell anyone. Just between you and me, Lina Mandla. I would check this one by replacing a value into the place of x. And the value that I'm going to replace, I'm going to show you on my calculator quickly, is I'm going to replace the value of, is it now period 3? Okay, now you need to go, otherwise. What's the next video? How you can check this on your calculator. I thank you, grade 11. Have a lovely day. Do subscribe and thumbs up.